Welcome to the meeting room at Global TV Talk Show, a broadcast service of globalbusinessnews.net.
Now, here's your host, Ed Cohen.
This is Ed Cohen in San Diego, and it's Valentine's Day, February 14, 2022. And it's a little after 9 a.m. here in Southern California. Spring day, or actually summer again. It'd be about 80 degrees. Amazing, isn't it? Crazy. I wish it would rain, but the sun is okay. A very special guest today is Dr. Jeanne Loring, who is a renowned stem cell sciences science researcher, and is in an emeritus position with Scripps Research, and she's going to tell us much better and more detail than I was just in about 30 seconds from now. Also with us is Mark Nadich, who's a business executive, and he's based in the Milwaukee area. Hi, Mark.
Hello, Ed.
Welcome again. And Mark Colo is my co-host on what we call medical TV talk shows, which is a unit of globalbusinessnews.net. So, Mark Colo, why don't you quickly give us a quick overview of the doctor, and then we'll go to the doctor.
Boy, I wish I could give you as much as she has to tell, I'm sure, but I've followed her, tracked her for some time now. I met Jeanne about 6 years ago, I think, maybe six, or maybe about 6 years ago. And I was able to participate in one of her fundraisers. I don't know if you guys see that or not.
Briefly.
You probably remember that shirt, Jeanne. I still have it. It's still in pretty good shape. But, it was a fundraiser they had down in San Diego. But everyone that I know that knows Jeanne has very, very good things to say about her. And I'm hoping that she'll be integral in helping me get beyond this Parkinson's, because I can think of nothing more grand than to be able to just sit still, calmly, and to process things the way I once could. So
it's been a learning lesson for me to get to know you, Mark, and to observe. Dr. Loring's work provided the methods for differentiation of autologous-induced pluripotent stem cells into dopaminergic neurons, I'm reading this, which form the basis for Aspen neuroscience. Dr. Loring, welcome. Tell us about that.
Thank you. Thank you very much. So my project my background is in biotech and academia. I guess my greatest areas of expertise are stem cells and genomics, DNA sequencing, and what's called epigenetics, which is the sort of overlying control over what part of DNA is active or not. I'm interested in a ton of other things, but I'm going to try to focus on just this one application that my lab developed. Stem cells are we have very few stem cells in our bodies right now. We can regenerate our blood system. We can regenerate some of our liver. Not too good at regenerating anything else, especially the brain. So the stem cells that I work with are called pluripotent stem cells. Those are cells that were first discovered in very young embryos from IVF clinics before implantation. They were the embryos that were left over after people did in vitro fertilization. Those were called embryonic stem cells and then you could capture them in a culture dish and keep them forever. And it's been shown that they can become every cell type in the body. So you've essentially just captured them at the time in which they have tremendous powers. That's why they're called pluripotent.
May I interject a question here?
Please.
What is a stem cell and where do you get it?
Yeah. So there are two kinds of stem cells. There are the stem cells that are in our bodies right now. And they're in various organs, but really the only thing they're any good at is replacing some cell types in those organs. I don't want to start talking about the clinics that are offering stem cell therapies. I maybe at the end I will. But those are not at all like my work. Our work is very, very precisely and scientifically based. Embryonic stem cells are not in our bodies. We do not have any cells in our bodies that are capable of making every cell type in the body. I mean, it's too bad. You did once when you were about, I think about 5 days after you were a fertilized egg, you had those cells, but no longer. So, but amazingly, and it's a long, long, long period of work that came to this the human equivalent, the human pluripotent stem cells that come from embryos were developed, were isolated from embryos in around 2000. So this information has been around for a while, and the great thing about them is that they're cell lines, and so you can just they keep dividing. I'm going to mention the word cancer cells, but they are not cancer cells. They have all the qualities of cancer cells, that they grow really, really well in a culture dish, and they will just keep doing that. So you have, you can put them in a liquid nitrogen freezer and save them, thaw them out, grow them up again. So if you've heard about HeLa cells, they have that quality of HeLa cells, not any of the other bad things about those cells. So, but let's jump ahead just a little bit, because once pluripotent stem cells were starting to be studied and from embryos, a young Japanese scientist named Shinya Yamanaka did an amazing set of experiments in which he took skin cells, first from mice and then later from people. And he figured out how to use a molecular transformation to turn those cells into pluripotent stem cells, just like the ones that you had when you were 5 days old. They're called induced pluripotent stem cells because they're induced to become like that, but they are identical to the cells you used to have. I think that speaks to the fact that your DNA hasn't changed since you were 5 days old. You have the same DNA. It's really the epigenetic, the on top of DNA control, that allows your cells to become pluripotent stem cells again. So that opens the door to some unbelievably cool stuff that you can do, because that means every one of us can have our own pluripotent stem cells again after we've grown up. And they're cultured in a dish. They do not grow in your bodies, but they are cultured in a dish. And over the years, we figured out how to turn those cells into very specific cell types. And that's their important use. So if you have a disease in which a particular cell is lost, and I mean, there are a couple of examples. One of them is type 1 diabetes. Type 1 diabetes is caused by the loss of the what are called the islet cells that make insulin in the pancreas. And there's no recovering it. Their cells don't grow back. So that's why people have to take insulin all their lives. But there is a clinical trial right now, and an experiment on humans. That's what it is, but it's overseen by the FDA, going on right now to replace those islet cells with islet cells made from pluripotent stem cells. So now you're constructing something that's missing and you're adding it back to somebody. The other example.
So is it possible to enter for research? Is it possible to enter the developing embryo at that 5-day period?
No, not much. Well, I kind of think it's a bad idea, because what happens to that embryo will affect the development of that human being in ways that we really don't want to mess with.
Right. You're right.
So I think certainly some people have done stuff like that, but I don't think that's going to be very popular. It's just, there's just too much about biology we don't understand. Yeah,
and we don't want to mess with God's creation.
Well, it's embryos are absolutely miraculous, and we have so little information about how it is that they form and how they manage to develop into human beings over 9 months. I mean, it's astounding, and we do not understand that. That's much harder than physics in my mind. So now that we have these cells in culture dishes, really the sky is the limit. We can just imagine the things we can do with these cells. If, as a scientist, even if you're not a professional scientist, you can start thinking in terms of what you think might be science fiction, but it might not be, because we have these tools now. So the other cell type that needs to be replaced in a disease is a cell type called a dopamine neuron in Parkinson's disease. People who have Parkinson's disease over time, over their long lives, usually, start losing these cells. These cells, dopamine neurons, in one part of the brain. They exist in other parts of the brain, but these particular ones are in a part of the brain called the substantia nigra, which means black substance, substantia nigra. All the brain parts were named with Latin names, which is kind of cool, but sometimes hard to remember. So the substantia nigra is where the dopamine neurons live, and they send out their axons, their projections, their connections to another part of the brain called the striatum. It's that connection between those two cells, those two parts of the brain, that breaks down in Parkinson's disease. And the outcome of that is that people have numerous problems with movement, tremor or freezing, or there's a whole list of them. They can be very subtle, or they can be really large. But the fundamental cause of all of them is the loss of that connection, the loss of that circuit. So the idea to treat Parkinson's disease is to restore that circuit. And I think you can start thinking ahead about how you might be able to do that with pluripotent stem cells. There are two aspects. One is to take pluripotent stem cells from anybody's skin, take skin cells and turn them into pluripotent stem cells from anybody, and then take those cells, turn them into dopamine neurons, and then put them back into that person's brain. It is conceptually really, really simple. And it's not that difficult in the lab either. The main problems with it are just little kinds of things that you have to develop to make sure the cells are safe, make sure the cells are going to become what you want. One of the problems with cells being pluripotent is that they want to make everything. And so you have to restrict their ability to do that as you make them into dopamine neurons. So once you get to the stage where the cells are absolutely going to become dopamine neurons, they can't do anything else, then they can be transplanted into somebody's brain, and they're put into the striatum of the brain, which is the place where the substantia nigra connects. I'll pause for questions.
Mark Natish, do you want to jump in here?
Well, I mean, it's amazing information. I guess the thing that I am always intrigued by, and from maybe my experience in working in pharma organizations, is the criticality of partnerships between academia and other organizations. And I'm just curious about how that, in the work that you're doing, in what you just spoke about, how that all connects.
No, that is the big question these days in regenerative medicine, is what we call regenerative medicine. So to make a long story short, I got to the point in my lab at Scripps in which I thought my team was ready to start developing this as a therapy for humans. And that's when I started Aspen Neuroscience, because the critical part that's missing in academia is the large amount of funds you need in order to make a drug and do a clinical trial. You just can't. Some people have achieved it somewhat, but the easiest thing is to just start a biotech company and take your technology and your intellectual property with you and just go for it. So that's what I did.
So you called it a drug, but it's not a drug until later. But so what's a better name?
What do you think, Mark? Being from pharma, I think of things as being drugs are small molecules. They're medium-sized molecules. They might be DNA, they might be RNA, like in the vaccines,
Right.
or they might be cells. The whole
Yeah.
thing is a drug-like substance.
Right.
Yeah.
Yeah.
Okay. So obviously, when you're working with such minute particles,
Oh, they're small. Yeah.
and so precious, how they're handled during that process and where exactly they should be placed in the brain.
Mm-hmm. Yes.
That is like amazing. I mean,
We're talking about variables here, which are the bane of any scientist's existence. The unexpected, unaccounted variables, the ones in which things do stuff that we didn't expect. We try to keep those to a minimum, and we try to test every single one of those variables. That's why it takes so long. We started this project in 2012 in my lab at Scripps. Those are really, there was a lot of knowledge gained, not just by us, but by the field was growing like crazy, and we got information from everybody. I continue to have worldwide collaborations with other academics. Now that I'm in a biotech company, I'm still an academic. I'm still at Scripps, but my lab has moved to the biotech company. Now we start talking about the practical aspects of getting a therapy like this, a drug like this, into people, and to test it to see whether it works. So, en route to doing that, you do a lot of studies with animals. We do safety studies with rats to make sure that the cells don't do anything that we don't want them to do. We do efficacy studies with rats, which is essentially to putting the human cells into the part of the brain that is equivalent to the human target of those cells. And it turns out that you can cure a rat of induced Parkinson's disease you can induce Parkinson's disease in a rat by killing off those neurons. And you can cure it by putting in human neurons. That's pretty powerful. So
yeah, wow.
Yeah. So and then this is where the FDA is learning along with us. And I think it may not be a direct connection, but it's sort of like a mind meld with the FDA through many other connections. They read things that I write, they read things that other people write, and they get a feeling for what is going to be necessary for them to think it's okay to do this.
So the testing process, what makes it so long and divergent, I guess is a better word. It depends on who's the testee. Who's.
Mm-hmm.
I may take that medicine, we'll call it medicine,
Mm-hmm.
differently than Mark Nadich.
Right.
I mean, I just got a chill thinking about that.
Yeah. So let's turn to this term autologous. That means same or self, right? So we're trying to avoid all of that kind of interference that we can't predict by taking somebody's own cells and then making those into the dopamine neurons that we'll put them into that person. So whatever little quirks there might be about somebody else's cells, we don't have to worry about those. We can worry about other stuff, but not that. And you don't need to be immunosuppressed, which is also, I think we all have learned in the last 2 years, is really important. Being immunosuppressed means you're more susceptible to infection by viruses. So someone's own cells, put them back into their own brain, I think is the best possible solution for a cell replacement therapy, or best possible approach to a cell replacement therapy. And so right now, the company is moving into will be known as it's not started. We don't know when it's going to start because it'll be in the hands of the FDA. But the first phase of a clinical trial is called a phase 1, and it's very few patients, very few people. And what the company has been doing over the last several years, the company was founded in 2018, and we got what's called startup funding or seed funding of about $6.5 million at the end of 2018. And then at the end of 2019, going into 2020, we got $70 million, which is enough to actually, populate the company and get and pay the rent. The problem was that precise time was when COVID started rearing its ugly head. And so everything got slowed down because of that. Everything was more difficult. Believe it or not, it is hard to get certain things that you need in the lab because they come from China on ships. And so everything, all of the science like that has been slowed down, and it's speeded up again now that things become more available. But the people working in the lab were really relentless. They just kept moving onward and figured out ways around a lot of these issues. So right now, the idea is to get feedback. Next step is to get feedback from the FDA about whether the clinical trial that is planned would seem to be safe as far as they're concerned, that we would not harm the patients. A phase 1 clinical trial is formally only a safety trial. However, you always want to put your best shot out to start with. And so you want the people who get treated in that phase 1 trial to also recover from the disease.
Well, let me ask you, it's not a political question, strictly business, but why China? Why can't we make it in Arizona?
Because we started making it in China, and we started getting stuff from China. This supply chain has become hopelessly intricate, and so much has originated in China. There was no motivation to do it in Arizona because it would cost more, just like everything else, that we use, all electronics and everything. It was cheaper to have it done in another country than do it in the US. Not that we're not capable of it, just we have to be willing to pay the price. So that is changing in we call it the reagent space, because there are all these things that we have to get in a science lab in order to keep that science lab going, to grow the cells, to feed the cells, to look at the cells, to analyze the cells. All of those things have required a whole spectrum of these chemicals in most cases, sometimes instruments that have their origins in some other country. So everything gets slowed down. The good thing about our project, and the reason why we could really survive, was that when I left Scripps, I brought my entire lab and all of my equipment to my company. So I did a smooth transition straight over into a company from an academic lab. I didn't have to train anybody. I didn't have to buy anything. It was really like we hit the ground running.
So if I may ask about that, so Scripps is, as we both know from San Diego here, wonderful organization, doing many things. Did they make this as a donation to help make things work for you? Yeah, good.
Yes, but I have to admit that they didn't realize it at the time. But that's exactly what they did. I made it very attractive to them to donate the equipment, and they hold everything I invented at Scripps belongs to Scripps. So the company had to get a license for it, but the license terms were very generous. So in a sense, our timing was absolutely perfect for that, because at the time, and maybe Scripps was downsizing at that time. They had, in fact, the lab that I used to occupy went in 2018. It's now been completely gutted. The whole building has been gutted, and it's been turned into new research space because it didn't belong to Scripps. It was leased by Scripps. So there's a lot of that kind of thing that happens. Yeah.
We are pleased to welcome Adamo Education as a proud sponsor of Global TV Talk Show.
The concept of a micro school is the reimagining of the one-room schoolhouse. My name is Tamara Becker. I'm the president and CEO of Adamo Education. The micro school concept really does not just lend itself to the personalization and the customization of learning, but also the social development and fostering that sense of love for learning. Unlike what we see in traditional brick and mortar schools, we have multiple grade levels in the same learning space. Students can be enriched by the socialization that they get, as well as the academic support from peers. What differentiates Adamo is the fact that we are taking the best pieces of brick and mortar, of digital, and then at-home learning. Students here can come 5 days a week. They can come 4 hours a day. It will really just depend on what is best for the student and for the parent. To enroll, just reach out via phone, text, or email, and we'll have that personalized conversation, and we'll be able to get you all set up. Check us out at adamoeducation.org.
Hi, this is Ed, and I thank you for tuning in to Global TV Talk Show, a unit on globalbusinessnews.net. We broadcast to the world, as you know by now. So I wanted to make sure that you understand that our programs are advertising supported. We're grateful for co-sponsors, advertisers. They have a marketing budget, coupled with a strong desire to be associated with our top quality program. And of course, I'm grateful. Thank you. So for the next few minutes, you're going to see some commercials. It's mostly very low key, and our prices are very, very reasonable. Our exposure for the advertisers go 12 months and beyond. Some of our advertisers have been with us since March, April of 2020. And Google Analytics has tracked over 125,000 what they call audience page views, which means you looking at this page, that's a page view. Now, if you happen to go to one of our other shows or to our radio broadcasts or to our newspaper or magazine, those become additional page views as measured by Google Analytics. And so when they say 125,000 since spring of 2020 up through Labor Day, a month ago, that's pretty good numbers. And the past 30 days, Google Analytics has measured just under 6,000 audience page views. And that, according to them, is a 42% increase in audience participation over the month of August. So thank you very much. Well, here's our advertisers, and we'll be back in just a couple of minutes or so, and we'll proceed with this interesting conversation. Thank you.
This episode from the meeting room of Global TV Talk Show is brought to you by
The Bridge School, the accredited international online private school of choice, at bridgek12.org.
Porch Light Rental and Destination Services. Reduce your renter lump sum or managed relocation costs. Visit them at porchlightrental.com.
And by airs.com. With our full range of services, we can help design and manage your international relocation. Find us at airs.com.
Primestone Partners, featuring corporate, government, and developer housing solutions, as well as senior-level advisory services. Find them at primestonepartners.com.
And by International Auto Source. We are the vehicle experts for expats, featuring all major brands of automobiles with flexible solutions and financing. On the web at intlauto.com.
Become a global player in your field.
Cross Culture to Go provides virtual support for your global business and career success.
We can help you thrive in 140 plus countries and markets.
On the web at crossculturetogo.com.
Something that's really neat is that the Bridge School partners with various organizations to provide learning for their students. For example, we partner with a major ballet company, and we are able to enroll several of their students into our school. So now not only is the student able to participate in a school and have a seamless transition while they're very active in their ballet career, but now they have other dancers that are with them that are doing some of the same courses. So it's almost becoming a camaraderie where they're taking similar courses, they're working together on their ballet, and really being able to form this great partnership with these organizations to provide a needed service. A lot of times there are student athletes who will spend hours and hours at the gym or at the basketball courts, wherever it is. And if they're attending a traditional school, they're in school from 8 to 3. They get a quick snack, and then they're at the gym for 3 to 4 hours in the evening. Coming to us and having that partnership, they're able to break that up throughout the day. They can have a morning practice, get some schooling in, have an afternoon practice, finish their schooling in the evening. So there's that flexibility. And additionally, if there are tournaments or performances, it's fantastic because if there's a week where they have shows straight through, they can take that week off of learning and then pick back up when they're done. So it offers this great flexibility. And for the program owners of these sports leagues, it is a win-win situation for them because they see this need. They see this need that their students need to make sure that they are obtaining the grades necessary to be successful adults in our country and in other countries. But it provides them an environment where they can be successful at both.
Hi, I'm Sergey Gorbatov.
I'm Angela Lane.
Together we are researchers, writers and practitioners in the field of human resources.
And we've also been multi-country, multi-assignment career expats.
We owe our professional development and growth to a very large extent to the international assignment opportunities that we have had.
But in a world where distributed work may become the norm, we also want to understand what will happen to the nature, duration, and purpose of international assignments.
Together with our colleague, Julian Dalzell from the University of South Carolina, we're undertaking a study on the future of expatriation.
And we'd value your contribution. You can participate in this important study by completing a simple 10-minute questionnaire.
Access the questionnaire by typing in your browser tinyurl.com/expert study. That's tinyurl.com/expert study. You can also find the link here on Ed's website next to this video.
Thank you for joining us in this study. In return for your contribution, we'll provide you with a copy of our research.
And of course, you'll be invited to an exclusive webinar hosted by Ed, where we will share our findings right here on Global Business News.
And so please go to tinyurl.com/expat study. Take the survey so that we can better understand the future of expatriation.
So this research is geared for people like Mark Colo, or Mark Nadish's friend, and yet it sounds like there's a lot of development going on, and yet are you saying that it's I'm going to use the word and just tell me to keep quiet and if you don't like what I'm saying, dangerous to start using it now?
Yeah, it's always dangerous to try anything in humans. Every drug is dangerous. Some of them remain dangerous, and the FDA puts black box labels on them to warn people who prescribe them that they could be dangerous for certain kinds of people. Yeah. I think we're taking the safest possible route. We still have a brain surgery component, but it turns out that this is the easiest form of brain surgery. If you talk to a neurosurgeon, they'll say, yeah, piece of cake. This is not complicated stuff. We essentially put a needle into the brain at the right place, which involves drilling a small hole. Let me know if you get grossed out. Growing a small hole in the skull, and then inserting a needle, and then using that needle to release the cells into the right place. And then you pull the needle out, patch up the hole, you're done. The only risk really is of infection, and neurosurgeons are well aware of those risks.
Fascinating. Mark Nadich?
I'm just curious, Doctor, about what is the timeline as you think about progress being made in the early phase 1, and where do you think that's going?
Yeah, so there are 2 trials already going on now, essentially with the same purpose and the same cells. One of them is being done by a company called Blue Rock in New York, and the other one is done in Japan, in Kyoto. The difference is that those 2 got a jump start. They went faster than we did because they are not using a person's own cells. They're using a one size fits all off the shelf single cell line. And those people have to be immunosuppressed. So we're gaining a ton of information from their experience. And it's really valuable to have other people. You're not out there doing something all by yourself. There's always somebody else doing something similar. So we're gaining information about the safety of this approach. The FDA is learning that this approach is safe. We've already benefited from someone else's experiments. Those are both in the early stages of phase 1 still, because they started very recently. But there have been no reported adverse events, which is what you have to report to the FDA or whoever the regulators are. So the people who have been treated have had nothing bad happen to them as a result of the transplant of the cells. And then one of the things about neurons, and this is why being patient is not easy. You want to see something immediately, but these cells that we put into the brain, they now have to send out all these little fibers to all the cells in their target, in the striatum, and make connections with them. And that takes time. In a rat, we'll see that happen in 6 months. We don't know how long it'll take in a human.
So somewhat related in my head anyway, but what about the variant, the Omicron or whatever it's called, and it's splitting, mutating or something? What causes that, or what allows that to happen?
It's evolution is what it is. It's the survival of the fittest. It's a great kind of concept for just about everything you look at. The survival of the fittest, because there's not room for, if something is better at something, or in a pharma case, one pharma is a lot better at one disease, all the other ones will fall away and it will take over. So it's evolution is happening in our lives all the time, the survival of the fittest. So the Omicron variant sort of took over because it was the mutations that were randomly acquired by the virus turned out to be incredibly useful for the infection to be transmitted a lot quicker. And all a virus, if you want to think in a virus's head, if viruses had heads, all they want to do is survive and make more of themselves. Any biological organism fundamentally wants that. So by being more infectious, it just completely aced out Omicron. It's sort of like if, oh gosh, let's think of a company that did really well, like they were the Pfizer of the viral world. They came up with, Pfizer came up with this vaccine, the vaccine, the RNA-based vaccine that worked, and all the other companies, or most of them, just sort of fell away. They became the dominant provider of vaccinations because they were better at it. they and their partners are better at it. So I know I know this, the whole thing sounds a little weird, but the survival of the fittest goes on all the time. I won't even tell you what it does in academia.
Well, Doctor, I really appreciate having you on the show. Mark Colo, what can you do?
I have a question for Jeanne. You mentioned a word earlier, and I talked about that word, and Ed wasn't sure what it was all about. Epigenetics was the word.
Yeah.
And I'm wondering what tie-in epigenetics has with Parkinson's or these other neuro diseases. What's the connection there?
Oh, it has a huge connection. So you have the same DNA sequence in every cell in your body. A couple exceptions in the immune system, but let's just assume you have the same DNA. Epigenetics is the complicated way. So epi is on top of genetics. That's literally what it means. So you take those DNA strands, and they contain genes. And epigenetics is the whole suite of processes that decide whether this gene will be made, will be expressed, will be like the genes that are required to make dopamine. In dopamine neurons, you do not want the genes that make insulin to be on, right? Epigenetics turns those off, but they're still there. You haven't changed the DNA at all. They're still there. They're just suppressed.
Yeah.
So epigenetics is absolutely fascinating because we're using it all the time, but we don't fully understand it. Every cell in your body has the same DNA, but different genes are turned on or turned off depending on what cell type that is.
So this is impacting the reducing effectiveness of the COVID vax.
That's right. And that actually is, that probably wasn't the reason why it did so well. It's probably that it's so infective. All of us who are triple vaxxed are likely, there's a fair chance that we will get it anyway, Omicron, and we'll be sick for a day and we'll be fine because we have antibodies that are almost effective, completely effective. If there is another variant that evolves somewhere that can evade your own immune system and all the antibodies you've built up against that initial COVID virus, then we're going to be in big trouble. And that's why I think when you talk to scientists, they're always sort of like, well, we're not sure because we can't tell, because it might happen and we don't know exactly how it'll do it, but we know it wants to do it. Or we know that the virus wants to just keep spreading. So everything we can do to suppress it from spreading is really important.
Mark Colo?
Yeah. There's a scientist that just recently passed away. He used to be at UCI campus. His name was Paolo Sassoon Corsi.
Yes.
And he's a bright, brilliant guy. Everyone on the campus loved him. But he passed away. He had a heart attack. And his wife is actually a neurologist. Her name was Emiliana. But he's done so much work on this epigenetics. Estee Lauder was one of their funding groups. And Estee Lauder made a short movie clip. It's like a documentary on epigenetics. And
interesting.
Have you seen that, Jeanne?
No, I haven't. I can probably learn how to explain it by watching it.
You could. He did a great job. There were 3 people on it. And if you look up, go on YouTube, just type in Nightbirds.
Nightbirds, okay.
Nightbirds, 2 words. And it'll come up. Great. And some of it's filmed at where Paulo lived, which is Laguna Beach. My second
well, that's not a bad place to film.
My second favorite place to Del Mar.
Second to Del Mar, right?
So, Dr. Loring, I don't know whether it was Dr. Fauci or somebody else was saying recently that we all may need a 4th shot or a more regular, almost like the flu shot every year that I get. It's just another COVID shot.
Yeah.
Because of this breakdown.
Yeah. Because of the evolution. Evolution is at the basis of all this, and it's always going to be, like I said, over and over again, it's survival of the fittest. I mean, we're all here today because we had what it took to survive to get this old, right?
Mm. Yep. That's it. Well, this is, well, thank you for sharing your knowledge. I don't want to let you go, but I'm sure you have more important things to do.
Well,
Mark.
I don't know. You know, these days it's whatever I feel like mostly. But yeah.
Yeah. Mark, Natish, do you want to explain more about what happened with your friend, as far as you know?
Well, just very briefly, he started, struggling with kind of general, motor skills, forgetting, and and it's moved to the point now where in the not too distant future, he probably won't remember me or his family. And so it's been an evolution over a few years, but what we're just trying to figure out is, and Mark's been amazing, and I so much appreciate the introduction to him, is just trying to help find resources for him and the family to have a way to, kind of manage a very difficult disease, as many people, go through their life. But it's every week we get to walk with him, and it's a club of men that have great connection to him, and we enjoy the opportunity to spend time and also a little bit of a respite for family.
Yeah. Can I, Mark Colo, do you mind if I spend 30 seconds talking about Summit for Stem Cell?
I wish you would.
Great.
So there's a foundation that was founded specifically to support my work, which is another one of those miraculous things that doesn't happen very often. It's called Summit for Stem Cell, and it was started by a fundraiser in which people with Parkinson's disease climbed to the top of Mount Kilimanjaro.
I've heard of this, yes.
And sent us a check for $250,000, which is an incredible amount of money if you're an academic.
Whoa.
And that's what turned us to this project. And they continued to fund us. All in all, over time, it was about $3 million that they managed to raise, that I didn't have to write grants for, that I didn't have to try to get philanthropic money for.
Wow.
And a lot of what you pointed out, Ed, in which Scripps was so cooperative, was because Summit, being a nonprofit, it was very easy to negotiate for donations to the nonprofit, which then grew into the company. So the idea now that they have succeeded in their view by launching a company, which will lead to clinical trials, they are now turning to patient support and patient family support. And they've just announced last week, I'm on their board now. That was one of the I guess that's the punishment for being involved with them so long. and we therefore are launching a capital campaign to raise enough money to start a Parkinson's disease and other neurological diseases eventually, first focused on Parkinson's, a wellness center in which I get to talk about science to people, and MDs, neurologists, get to learn from other neurologists about how to treat the disease. And families get to meet other families, and they can talk about what works for them or doesn't work for them, or just what it's like to get a diagnosis. So we're all working very hard, and it's going to be a physical space as well as a virtual space. It'll be down here in Del Mar or Encinitas or somewhere in the San Diego area, because everybody wants to come here, right? And so I think it's going to become a reality. I saw what they could do before. I think they can do it again. So it's the role of patients and patient advocates cannot be underestimated for any of these areas. It's just you have to be outspoken. You have to understand the science, because that gives you strength, that gives you power. And if you understand the science, then you can get other patients involved and other people involved. And it's a magical connection.
So, Dr. Loring, I welcome you to come back on medical TV with Mark and Mark, and I wish you well. Full disclosure, my primary physician is tied in with Scripps, and so I'm very familiar with Scripps, and they're great. Yeah.
Yeah.
So I think the Anderson Cancer Center is part of that area up here in La Jolla. Yeah.
We do have to make sure we understand. There's Scripps, and then there's 5 other Scripps.
Yeah.
I was in Scripps Research, not in Scripps Health.
Yeah.
So my work was it was a research institute. So I didn't have any direct connections with the physicians in Scripps at Scripps Health.
Got it. Good. So please come back. Mark Colo, thanks very much for doing this, and we wish you the best.
Thank you, Mark. Thank you, Ed, and thank you, Mark.
Yeah, thank you, Doctor. Amazing work you're doing. Just amazing.
Thanks.
Thank you.
Thank you.
This is Ed signing off in San Diego. This program will be available on demand, free, 24/7, 365, going forward for the world to learn from it. Thank you.
See you all soon.
Bye-bye now.
Thank you.
Thanks. Bye. Thank you.
Thank you for joining us in the meeting room at Global TV Talk Show.
Have a wonderful day, and stay safe.